To understand what WebSockets are and to understand how its communication happens, let's see how the WebSocket model differs from the traditional request response model. In the traditional request response model, the client initiates a request to the server, and as a result, you will get a response back to your client. In the WebSocket model, it uses a bidirectional communication. So the clients and the servers can send messages to each other, unlike in the traditional request response model. So how this communication flow happens is from the client, you send a request to your server, and that point there will be a WebSocket connection getting established. So using that WebSocket connection, the client can send either one or multiple messages to your backend to process, and also the server can send one or more messages to your client. So throughout the life cycle of this WebSockets connection, both the client and server will be able to send messages. So this bidirectional communication that comes with WebSockets comes very handy when you're dealing with chat applications or real-time dashboards where you want to show the real-time updates to your customers. So let's take a look at the architecture diagram for the demo today. So you have a client connecting to a WebSockets API gateway, and you have 5 Lambda functions to support this functionality and a DynamoDB table to manage the session data. Let's say the client want to create a WebSockets connection. So that time a request will get reached into the WebSockets API gateway and then to the connect endpoint. And in here we can access all this connection information using the event and the context objects, including the connection ID details, and we can store those information into the DynamoDB table for later use. Similarly, if the client wants to disconnect from the WebSocket connection, then the disconnect route will be used, and here we can write code to remove the connection ID information by looking at the event and the context object into the DynamoDB table. And these 3 Lambda functions are used to handle messaging. So when you want to send a message from front end to back end, so we have defined an endpoint called message. So this is the route that it will go through. So when a client sends a message, it will go to the API gateway, and then it will go to the messages endpoint, and in here we can write the code to process those information. Similarly, we can use the notify Lambda function to notify your clients or broadcast messages to your clients from the backend. And you can see there's a default Lambda function as well. So that Lambda function is used to handle any requests which are not defined. So for example, in our use case, we have defined a message endpoint. So if you are passing any events with the message action, it will reach function and can be handled from there. Suppose you are sending an action to any endpoint other than message, say announce or send message, or it could be anything. So that cases, since the those endpoints are not defined, then those messages will get routed into the default Lambda function, and you can write code to handle or log into your databases. So let's move into the demo and see how WebSockets API work in action. So as you can see, I'm in my AWS console now. So let's go ahead and create the Lambda functions we need for this demo. So in the search bar, type Lambda, and then you can right click and open in a new tab. Click on functions on the left pane. Click on create function, and we'll name the first Lambda function as WebSockets Connect. I'll use WS as the as a short abbreviation for WebSockets. And for the runtime, we'll pick Python 3.9, and for the execution role, we'll let the AWS console create IAM role with basic Lambda execution permissions, and click on create, and this will create your first Lambda function. So you can see your first Lambda function WS Connect has been created, and then let's create the other functions as well. So I'll open 4 instances of this Lambda page. So let's name the second Lambda function as WS WebSockets disconnect. So we'll use the same IAM role option. So the AWS console will create IAM role for us. So WS disconnect Lambda function has also been created. So let's go ahead and create the third Lambda function. Let's name this as uh, WS default, and we'll pick Python 3.9 as the runtime and keep the execution role as is, and click on create functions. Yeah, the default function has also been created. So let's go ahead and create the fourth Lambda function we need. Well, let's name this function as WS message, and pick the same Python 3.9 runtime and click create. So we have the fourth Lambda function also created. Let's create the last Lambda function we need for this demo. Click on create function, and we'll name it as WS notify. The notify function has also been created. So then we'll move into the AWS console and search for API gateway, and open the API gateway page. So since we are going to create a WebSockets API gateway, we have to select the WebSockets API option. Click on build, and in here you will have to give a name for your API. So we'll name it as WebSockets demo API. In this route selection expression, you will have to give a property which will be available in your request payload when you are sending messages. So based on that particular action, the messages will get routed into your Lambda functions. So let's use something like request dot body, and let's name it as message. So what we are doing is, in the request body, expect a parameter named message and use that for routing the messages into your backend functions. Click next, and in here you have to define a few routes. So click on add connect route, and click on add disconnect route, and also click on add default route. And then you'll need to add a custom route as well. Basically, the connect route will be used when your clients are going to connect to your WebSocket, and similarly, when the clients are getting disconnected from the WebSocket, this disconnect route will be used. And so, if you are sending any messages to non-existent endpoints, then all those messages will get routed into this default route. Click on add custom route. Let's name the route key as message, as we want all our messages to be sent to that message endpoint. And click on next. And in here you will have to map or connect your Lambda functions we created in the previous step with the WebSockets API gateway. So for the connect route, we'll choose and pick the Lambda function we created as WS Connect. So click on Lambda, search for our function WS. We'll name the function as WS Connect. Yeah, here it is. So select that function. And so similar to how we did in the previous step, select Lambda and search for WS disconnect and pick that function. And for the default, also you can select the default lambda function ws default. And for the and for the custom endpoint that we created as message, we'll have to map a lambda function, backend lambda function. So click on lambda and search for ws message and pick it. With these configurations, we have mapped the WebSocket with the Lambda functions. Connect with the connect Lambda function, disconnect with the disconnect Lambda function, default with the default Lambda function, and the custom endpoint message with the message endpoint. Click on next. In here, the API gateway will give you a default stage name, production. But if you want, uh, anything other than production, or you want multiple stages, you can of course click on this add stage and create a stage. So for example, something like staging also we can create if needed. But for this demo, we will just use the production stage. So I'm going to remove this and click next. So this shows a summary of our configurations, and we can click on create and deploy. So this will create the WebSockets API gateway and deploy it. So our API gateway has been created with the routes that we defined, and that has a Lambda proxy integration with the Lambda functions. So if you go to each of these route keys, it will be similar. You have a Lambda proxy to your Lambda functions. And then let's go into click on stages and click this production stage that we have created. So in here you have the WebSocket URL, which can be used by the clients to send messages to the server, and similarly the server to send messages to your clients. So let me copy and paste the code and then explain what this code does. For the connect function, we are going to remove the default content and we are going to replace the content that I have created for this demo. So simply in the Lambda handler, what we are going to do is we are going to print the event, and then we are going to print the context as well. Then we are returning a response with the status code 200 with the text WSS connected. So we'll since we changed the code, we need to deploy it. Let's deploy that. Yeah, that function is deployed. Then let's move into the WS disconnect function. So the disconnect function, I'm going to copy and paste the code for the demo. So I'm going to copy and paste the code prepared for the demo. So the event and the context and returning same status 200. This time the text will be WSS disconnected. So click on deploy. So as I mentioned previously, this is the function which is used when your clients getting connected to the WebSocket. and this is the function that is getting used when your clients are getting disconnected from the WebSocket. So you can write code to handle any any logics there. For example, if you want to track your client's connection ID, so for you to be able to send messages back to the clients later on from the backend, then here, and this is the ideal place for you to write those information into a DynamoDB table. So you can use the Boto3 library and write a put event to store the connection ID into the DynamoDB table. And similarly in here, when the clients are getting disconnected from your WebSocket API, you can use the same mechanism to remove that particular record from your DynamoDB table. And in the default route, let's update the code in there as well. So I'm going to remove the boilerplate code and put the code created for this demo. So it's simply we are logging the event and the context, and then returning the status code with the text default route. So this is, this status is to just to identify we are in this particular, Lambda function. We'll deploy it. WS message Lambda function. So let's update the code there as well. So I'm going to remove the boilerplate code, and I'm going to paste in the code, and then I'll explain what this code does. So we are simply importing few libraries or dependencies. So JSON, we are importing JSON since we are using the JSON dependency in here, and we are using Boto3 library since we are using the Boto3 library to connect to the API gateway management API in order to send these messages. And in the function, we are just printing the event, and from the requests event details, we are capturing the connection ID, and we are constructing a message that will include the connection ID as well. And then simply we are going to use the client post to connection and pass the connection ID and post in the message created in the previous step. This particular message will get passed into your WebSocket client when the backend receives a message. So for example, if you pass this particular message from the WebSocket client, that message will get into this function, and as an acknowledgement, this function will send that information to the WebSockets client. So let's deploy that as well. And I think I forgot to mention one thing. So this URL lib3 is a library used in Python to when you want to send HTTP requests. So that's why we have used it. And then the final Lambda function. So I'm going to remove the default code and put in some code here. So similarly, we are importing the JSON, Boto3 and the URL lib3 libraries, and you are using the we are creating an instance of the Boto3 client to use the API gateway management API, passing the endpoint URL. So function, we are extracting the connection ID and the message from which is getting passed as an event information, and simply we are posting those information to the client using the connection ID. So this particular message will get posted in the WebSockets client. So we'll deploy that as well. Let's check the messages Lambda function, and okay, configurations, permissions, and let's click on the execution role and see the permission. So WebSockets management API will need to give some extra permissions. So we'll have to add a few more permissions in here. Just click on permissions and click attach policies. And in here, search for API gateway invoke. Yeah, this one, Amazon API gateway invoke full access. So for this demo, we can give the full access. So click on select this select this policy and click add permissions. So now our IAM role is updated with the Amazon API gateway no full access as well. So for the notify function also we need to do the same thing. So let's click on configure permissions. Let's open the particular role IAM. Click on add permissions, attach policies, and search for API gateway invoke and search. Yeah, this is the one. And add permissions. Okay, right now, so now the API gateway invoke full access permission also been added. So I'm going to close the both the IAM management console tabs. So since we updated the permissions related to these Lambda functions, WS message and WS notify, so we'll need to do a small change and deploy to for the changes to get propagated. So I'm going to leave a small space and deploy that. And the same thing I'm going to do into the other function as well. Leave a space and deploy. So let's check the payload. We are expecting to have actions. And here you can see request body message. That's the problem that we have. So we'll change these to request body actions and save it. So since we have updated the API gateway, let's go ahead and click on actions and deploy. So pick your stage. And since we only have production, let's pick that and click on deploy. And this will deploy your function. So let's from the WebSockets gateway, we'll need to pick the connection URL and add it into our WS message and WS notify lambda function. So I'm going to paste it over here and remove the space that we had on the front, and also I'm going to remove this add connection part which is at the end. I'm going to click on deploy and then move into the WS notify and do the same, leaving the trailing space and removing this part, deploy. So now let's head over to our WebSocket client and see and test our functionality. Click on connections, and in here you need to specify the WebSockets URL, WSS URL. So grab that from the WebSockets API and post it here, put it here, and click on connect. It's trying to establish the WebSocket connection. As you can see, it has established the WebSocket connection now. So now we can send messages to this endpoint. Click on send, and yeah, so this is the message that you have sent, and this is the acknowledgement you got from the backend with the connection ID. So if you look at the code, it's this is the acknowledgement message received to the server with the connection ID. So this is the message that we are seeing or getting into the WebSocket client. So now let's see how we can send a message from the backend to the client. So let's move into the ws notify, and in order to do that, let's create a test event. For the test event, we need connection id and the message. Okay, so create new test event, and post to, so we'll name it as post to client, and we'll need connection id, and we need a message. And I'm going to remove this extra property. For the connection id, we'll need to give this connection id that we got into the WebSocket client. So I'm going to paste it over here, and for the message I'm going to say, hey, new announcement here, and I'm going to save that event. Seems like an error. Okay, remove the comma at the end, and click on save. Then simply click on test. Now if we go into our console, we should see a message named uh, the new announcement. Yeah, we can see the hey, new announcement is there. So similarly, if you send it multiple times, so you see multiple messages posted in here. So that's about the demo, guys. Thanks for watching.